In this video, we're looking at the graph of the cotangent of x. Remember that cotangent of x is equal to 1 over the tangent of x. So we're going to use the same sort of strategy as we did for graphing the secant, which is 1 over the cosine, and graphing the cosecant, which is 1 over the sine. In this case, I've taken the graph of tangent and drawn it in I'm actually just using Desmos, but I asked Desmos to draw it in very lightly. Here's one cycle of the tangent graph. Wherever the tangent graph is 0, 1 over the tangent would be 1 over 0, which is not allowed. And that's so for the darker, heavier line, that's actually an asymptote. So wherever tangent is 0, here's another one, cotangent has an asymptote. Here's another one. Equally, wherever cotangent is 0, tangent has an asymptote. So for one cycle of tangent, let's take a look at how we got the cotangent graph. Well, as I already mentioned, when tangent is 0, cotangent has an asymptote. When tangent is 1, cotangent is 1 over 1, which is also 1. That's why they cross there. When tangent is very small, we have cotangent 1 over a small value is a large value. So we have these values here. When tangent gets big, 1 over a large value is a small value. So we have these values here. That's what happens between 0 and pi over 2, because where tangent is positive, 1 over tangent will also be positive. Where tangent is negative, 1 over tangent will also be negative. So that's where you get the graph of cotangent, and it looks very much like tangent, so you do have to be careful. Like the cosine, where we had like the sine graph with cosecant, where we noticed that the sine was 0, which was at 0, we had to have an asymptote there. So if you just have a copy of tangent, one cycle of tangent, and you just have, say, one cycle of cotangent, comparing them, knowing which one is which, will depend on, first of all, kind of which direction it goes. These ones start high and going left to right, they come down. That's the cotangent. The tangent starts low and going left to right, it gets bigger. That's one difference. And the other difference is where the asymptotes are. We've done enough of these now that I really think that that's enough for this topic. So I'm going to stop there. The next topic is graphing variations of y equals the cotangent of x. And it's just yet again an example of how to graph something like, for example, graph y equals -3 times the cotangent of, let's say, 5 times x minus pi over 3 minus 2. And we know how to do that now, right? If we took, for the cotangent, we recognize that this is a cotangent graph, and we took some points on the cotangent graph and shifted them and stretched them if necessary, that's how we get those other graphs. So I don't feel the need to make another entire video on that topic. The last topic in this section is called Using the Graphs of Trigonometric Functions to Solve Real-World Problems. Well, I'm not going to make a video on that either. The applications they throw at the ends of sections like this are pretty insignificant and frankly a little bit dull, so we're not going to look at them here. We will be looking at applications, so don't get too excited, but we're not going to do it here. That means that this was the last video for this section. And we're ready to move on to section 6.3, inverse trigonometric functions.